one administrative statement. These are my views, not those of DNB by definition. So my goal today is to explain what we try to achieve with the table constraint specification. What is it? It's a backward compatible extension of xBRL-CSV. So any xBRL-CSV processor currently out there should be able to just read this and ignore it. Its goal is to have basic but very efficient validation capabilities. And we need this. Looking at xBRL-CSV, the files will be very large. That's what exactly it is intended for. If we would process it as it is today, we would run into problems. To illustrate the problem, I have this example from a report that we received. It's for the single resolution board, and it's basically a table of liabilities. SRB has defined a rule that says, well, of these, let's say, 20 attributes on a given line, 12 of them must be present in the report. So they implemented a formula rule that basically constructs a sequence of all those facts, counts them, and then equates them, checks if the number is 12. If it's 12, it's fine. If it's not 12, it will raise an error. Technically, perfectly done. Works very well on small reports. We received one that had some 5 million facts in this particular table. It took us more than 24 hours to run this particular rule, which is, of course, dependent on our software solution. It's also dependent on the way that this particular rule was written. We wrote another one that ran on the same report on the same hardware within an hour. But the point is just to make sure or make clear that using formula on these kinds of structures with these kinds of volumes will create problems. I've said all this. Moving forward. So this is, the issue that I explained is an issue on a single open table. What I see happening in the coming years is that we are going towards more granular reporting. The way I would describe granular reporting is a set of open tables. Sometimes a few, sometimes many. This illustration is the logical data model that we use within DNB. What we do currently is we collect data from commercial banks, ask them basically to supply us with information on all the loans that they provided to their customers. And this is, of course, just a graphical representation, but what I want to point out here is that it consists of many tables, all of them open, all of them having mandatory columns, I would like to say. So if we already have a problem with one table, if we go to, let's say, 50 tables, we would have probably 50 times the problem. We would need 50 days to validate the report with the current setup. To make life a bit more complicated, we not only have these mandatory columns, we also have referential integrity constraints. So between those 50 more or less open tables, there are also constraints that if there's a value in this particular table, there needs to be a corresponding value in another table. So that's the problem, and I would like to hope that table constraints will help in solving the problem. So what we try to do with table constraints is to provide validation on the CSV levels directly. So before you're forced, in a way by the xBRL standard, to load all the data from all the files into a memory structure, we want to do validation on those CSV files. So we propose to have column value constraints, so looking at simply a single CSV representing the data from a single table. And these are the ones that we propose to have. I'll just point out two types. So we would directly check at the CSV file level, is it a date, is it a number, is it something different? And the second one, the optionality. So we could just read the file, check if column 4 is present or not. And just in that way go through it line by line. We had the issue that I had illustrated with the single resolution report would probably not exist if I could just process it on a line by line basis. That would solve the mandatory problem issue that I pointed out. To do the referential integrity, we propose to also have the ability to identify primary keys, unique keys, and reference keys. And a combined key, that's something that I'll explain a bit later. That's something that's not currently within the PWD version that's on the internet, but I'm having an example a bit later. But the key thing is that these checks will be done on the CSV file level, and we expect that by able to do that, we can overcome those complications of validation. To illustrate what we would like to have as table constraints, I have taken this example of DORA. DORA is a reporting requirement set by the EBA. It's an older version. There's a new one coming, but to illustrate the table constraints, I think it's good enough. The key thing here is that just like the diagram that I shown before, there are, in this case, 15 entities, each of them represented by an xBRL-CSV file. And all of them are structured in a table orientation way. So if there would be an entity like we have entities in scope, R20102, for all entities that they have to report, all information on a given entity would be on a single line. So it represents the table structure. And that is key for us to be able to reference those elements for referential integrity. So I'm going to illustrate the column constraints with this one. So these are the facts that need to be reported for each and every entity that's in scope. And I've taken from the example of the EBA in this case what kind of constraints there are. So we have type constraints, we have optionality constraints, and we have allowed values constraints that I would like to illustrate today, how they would be, let's say, put into the xBRL-CSV metadata. This is the structure that the EBA provided for the xBRL-CSV files, which I have, let's say, enhanced for table constraints. So to go back, the date, we would propose to have a table constraints addition saying this must be a date. Quite simple. Looking at the optionality, again, a constraint, but we propose to have, let's say, the default for optionality to be set to false, making it mandatory to report. So in order to have an optional value, I need to specify that it's optional. So leaving the table constraint structure away makes simply the fact or the column mandatory. Chosen values, as easy as adding just the strings that you expect or are allowing to appear in the file. Moving forward to the keys. I've taken these three. So we have assessments that need to reference a ICT service supply chain entry, and they need to reference a specific contractual agreement. This is the table of the assessments. And we have here the reference or the value, let's say, for the assessment that needs to appear as well in the contractual agreements table. And the same applies here for the ICT supply chain entries. And these four together would be the primary key as identified in the regulation. So again, how would that appear in the document? Reference. it would be something like this. So the reference, of course, needs to have a name, so we can address it. We need to describe which column we take the value from this table, and we need to identify the key in the other table where the value must be present. The way it's written here, we would link to the primary key. If you want to address a different key, say a unique key that's also defined for the parent table, you would provide the name of that particular key in addition. So you can both reference primary keys, unique keys, whatever you need. The same applies here. And of course, what's up to the person defining this, he needs to make sure that the values that are referenced here, so column 20 and column 30, of course, line up to the values used in the primary key. So those values must match with the order of the columns as they are defined in the primary key. And finally, we have this definition of the primary key. So something similar would be, of course, present for the other two tables that are being referenced here. And the way that I would see this work, so of course we need to first read the two reference tables, read those columns, build an index for those columns, and then we can just process this particular table row by row and just get a value from the column and check, does it exist in the index? All is well. If it doesn't, we fail. And we probably, most likely, we would reject the report because it's not structurally valid. Moving forward, an example of a combined key. The reason for adding it, looking at the granular reports that I know, what I quite often see is that groups are identified with certain set of attributes, and within that group, certain subgroups appear. So, for instance, as I've taken the example here, we have the group of customers, but customers can either be natural persons or they can be legal entities. For natural persons, the birth date must be always provided. For legal entities, always the VAT number and the date of incorporation must be provided. So one way to implement this would be to have 3 entities, 3 files. In so one file for customer, all columns being mandatory, one file for natural person, again, all columns mandatory, and the same would be done for legal entity. So in a way, an easy way to enforce that if it's a legal entity, it must have VAT number because simply the column is mandatory. The problem that we now in some way face is to make sure that each and every customer is either a natural person or a legal entity. We cannot have customers that are not a legal person, a legal entity or a natural person. So we need a way to enforce that every entry within the customer table also appears as, well, he must appear either in the natural person table or in the legal entity table, which I have more or less described here. The way to see this within the xBRL-CSV structure is like this. We would have the primary key defined for natural persons. We would have the primary key, of course, defined for legal entity. And we would have a primary key defined for customer with the additional specification that values for the primary key must also appear in the other primary keys. One thing to note here, this approach and this solution are under discussion. So again, these are absolutely my views, so not agreed upon within in the working group, but this is how I see this working. If the working group comes up with a better approach, perfect. A few remaining additional remarks. The one that is here, linting. What we envision is to have, to some extent, 2 validating processors. One to validate the reports, as discussed basically here, and in addition to have something that would validate the design of the table constraints, so checking if whatever you are defining as table constraints makes sense if you look at the taxonomy. But that would be then the only time that for table constraints you need to access the taxonomy. So, for instance, if you would be defining a table constraint that the type is date, then of course, let's say the fact that you are creating or looking at in the taxonomy must also be a date and not a string, something of that nature. So that's what we think would be done by a linter. And one comment that's not on the slide, it is dependent, of course, on the table orientation for the CSV structure. We've seen the EBA propose a different structure for their CSV file in which they have one fact per row. Then this whole setup would not work because the columns that I'm using here simply don't exist. So it is dependent on following a table-oriented CSV layout. But many regulators are looking at that structure in order to be able to use this kind of table constraints. Finally, so the specification is in progress, working hard on another version of the PWD. My personal hope is that we can have this done by the end of the year, depending on all of you to help, and have it as a recommendation by the end of next year, which would time perfectly with the use of xBRL-CSV by EBA, IOPA, SRB, and many others, I hope. So to summarize, the table constraints specification in progress enables the validation of very large open tables. And I think it's essential to have something like this, because we see the adoption of xBRL-CSV by many regulators. If they cannot do this kind of validation, they will say, okay, fine, I'll just define these rules on paper. Everybody will end up writing his own validator, and then we go back to the dark ages where we would be fighting each other who has implemented the specification in the best way. For me, one of the, in a way, main advantages of xBRL is having certified software, meaning that I will never ever have to go into the discussion with some vendor saying my implementation of the specification is better than yours. I will simply ask, is it certified? Almost. I'll wait until you are certified and then we will discuss further who's, let's say, better. And even if, let's say, a discrepancy is found, a difference is found, then we will hand it over to Paul and say, Paul, please clarify through the conformance which one is actually right. So there's a mechanism to solve even, let's say, inconsistencies or unclarities within the specification. And there's no other solution that would provide the same approach. So that's all I have to say on table constraints. Happy to take any questions.
Thank you very much, Paul. Any questions for Paul?
Paul, I hate to ask this question. It's an impossible question. How much do you think it's going to save us? So the EBA will put out for their compressed data format in xBRL-CSV that they can reduce files down to 10%. Do you have any order of magnitude? Is it implemented well? It's implemented in the way you're suggesting it. So what are we going to save in terms of performance time and things like that? Any ideas or no idea at the moment? It's just going to be better.
Well, if I have no basis to say any percentage of, but well, the example that we did for SRB, it took 24 hours to run, at least. If I'm just processing a CSV file, just reading it line by line, minutes at most. So,
and on something like Dora?
Dora is not that large.
No.
So it would still be useful because currently there's also no easy way to even describe these foreign key relationships. What you could, of course, do is write very complex formula rules involving accessing facts, accessing the type dimension attribute of the fact, and then trying to find it somewhere else. Even thinking about writing those rules makes me run away, let alone asking you to run them on a large file. And like this, it's easy.
I did say it was an impossible question, but yeah.
Well,
Thank you.
hopefully very small, very, very big difference.
Any others? Wow.
So the comment about saving, the previous question regarding the benefits from the approach, I think there will be significant. I mean, the way how the xBRL processor, most of them probably works nowadays when they are processing formula link base. There are no constraints about the facts placement in the report, right? So the formula processor to be executed basically requires all the facts to be in memory already, to have the full space of facts, to match them, to find which of them are from the same row, and to eventually check some constraints on them. So that's a very memory consuming thing, right? To load big CSV sets into the memory to be able to process formula link base. So here that alternative proposed solution is very different because it immediately enables streaming. So instead of preloading whole reports, here we can stream file by file, row by row, or some batches, and then simply do it with zero memory cost. And that's a huge difference, I think. That when the processing time will be much better for sure, much harder to estimate, but the memory consumption will be few levels of magnitude lower here, comparing with the formulas doing exactly the same. And if I can ask the question, which is a little different than this comment, the specification assumes that these table constraints will be verified before the report is loaded. So I'm wondering, as far as I understand, that's how I read the current specification. So and I think you mentioned also that today. So I'm wondering, is it really required? I mean, this is very much implementation thing for me. Is it done before loading the report, during loading the report, or after loading the report? And vendors may have different ideas how to optimize that to achieve that performance expectations of the regulators in the matter. So I'm wondering if this, why that appeared in the specification.
What I would expect is to have, let's say, a table constraint report validator who would just look at the facts and try to execute the constraints defined.
Right. So,
Next to that, there would be a table constraint definition validator that would look at the same constraints, but then check, do they make sense against the taxonomy itself? So it would be a different validation run only once at, say, design time of the table constraints.
all right.
Nothing more.
It creates some unobvious flow for me that we are checking data before we, when we say that let's do that before loading of the report, it means that we didn't yet check if this report is the correct OEM CSV file, and we are already checking the data, which creates an obvious, unobvious flow for me, right? But that's the implementation matter mostly. So.
No. Happy to see you join the working group.
Right. All right, thank you.
And focus more on this work.
All right, thank you.
Yes.
Yeah. Because exactly we need these kinds of feedback to make it work.
All right, clear.
Thank you.
Thank you.
Thank you.
Please join
Next
me.
Thursday at 3.
Please join me in thanking Paul, and thank you very much for your presentation. Most enlightening, and I'm sure we will continue.
I hope so.
Yes, thank you.
you.